For this project, I decided to look at how the presence of a Santa Ana wind event affects the growth and overall size of wildfires in Southern California. I chose to do this as a case study looking at the Sand Fire from 2016 and the Thomas Fire from 2017. The Thomas Fire burned under a Santa Ana wind event, whereas the Sand Fire did not. All of the data that I used for this project came from the NIFC, which is the National Interagency Fire Center. They had historic perimeters for 2000 to 2019 for each year. And I had to download three different sets because the Thomas Fire did go a little bit into 2018. The first thing I had to do when doing my analysis was to separate the specific fires I was looking at out of the whole year, because it showed every single wildfire that burned from midnight on January 1st until December 31st at 11:59:59. I had to separate them out from the data set, and I did it by their name because I did have a weird thing pop up where for both of them, there was another fire under the same name in a different part of the country, in like the Rocky Mountains in Montana. I deleted that. That wasn't necessary for my assignment because I was looking at California. I did that by the name, and once I had that separated out, I went in and I did a select by attributes to isolate by day and created new feature classes for each day. When I did that, I started with the Sand Fire because it burned for fewer days, only 14 compared to the 34 that the Thomas Fire burned for. So when I did it for the Sand Fire, I separated it by the date and created the new feature classes. And some of those had multiple entries for each day. There were different agencies that contributed measurements. It wasn't done by timestamp, so it was different measurements, or it was a thermal imagery versus a satellite type of thing. And then I wanted to just have the one boundary for that, so I took the new feature class that was created by the date and took it into a dissolve tool, which I could not get the just dissolve tool to work. I don't know if it was user error or if it was something with the data I was using. It just did not want to work. I went into the pairwise dissolve tool because it popped up in a little banner at the top to say that you could use this as well. I went into that tool and I was able to get it to work how I wanted to. The Sand Fire didn't have as many entries, so it was fine doing it that way, separating it by date and then going and dissolving it. But the Thomas Fire had more entries. It burned for longer, and that process was not very streamlined. So when I went to do the Thomas Fire, I did the select by attributes to get my day highlighted in my table. And then I went into the pairwise dissolve tool and I just created the feature class that way so that it just returned the big boundary, just the singular one that I needed, instead of having all the different little parts of it. It worked a lot better, worked a lot faster. I got through that one a little bit quicker. And actually, we'll start looking at how that ends up looking when I mapped it. So in the red over towards the left side is the Thomas Fire, and on the right in orange is the Sand Fire. Day one is the first day that we have any boundaries for either of them. It could be the second day it was burning, but they didn't start collecting that data until this day. They are on different dates because they were different years. They actually burned during different months. The Sand Fire was in July and August, and the Thomas Fire was in December and January. As you can see in the day one, the Thomas Fire is quite a bit bigger than the Sand Fire, and that remains true over the course of both of their lifetimes. As you can see, moving into day 2, day 5, day 8 and 5 look the same. Unfortunately, the camera is blocking the Sand Fire on day 8, but it looks the same as day 5. And then moving over to day 10, 14, and then day 14 is the last day that data was provided for the Sand Fire, so it was considered contained after that point. So starting in day 15, I've graded out to show that it was no longer active, meaning they no longer have overlapping timeframes. The Thomas fire continues to get bigger. And day 34 is the last day that there was data for the Thomas fire, meaning it was contained after that point. This is one part of answering the research question. It shows that a Santa Ana wind event does contribute to a wildfire being bigger than if it were to burn without one. And I used the attribute table. I turned off a bunch of the fields that I didn't need, but I used the attribute table and exported it to a CSV file, then converted it to an Excel workbook to do a little bit more work. And this is one of the tables I created. This one I figured would be one of the better ones to show. This is the acreage difference for the first 8 days of activity. The first 8 days are when I have consistent data for both wildfires. After that, there's some days missing, which is why the mapping was done bouncing around for different days, because I didn't have data for some and I did for others. So for the first 8 days, we're going to ignore day 2 to 3 and day 4 to 5 for just a second. So for the first 8 days, the Thomas fire is growing a lot faster than the sand fire. The sand fire actually starts to decrease in size a little bit from day 5 to 6 all the way up to day 7 to 8. I am unsure if the negative values for day 2 to 3 and day 4 to 5 are because of user error, or if there was missing data, or if it really was shrinking at that point. I do find it a little hard to believe that the Thomas fire burning under a Santa Ana wind event would decrease in size by 273,000 acres over the course of one day. It is possible that it could have done this. I do not know at this point. I just find it kind of hard to believe. All of this occurs, if I go back, right down here is Los Angeles. This is actually close to where the Palisades fire was burning at the beginning of this year. I find it kind of odd that within a couple of years we've had two in the same spot. But this table with the growth, I did not do it down to a rate, just the in general growth of these wildfires, goes to answer the second part of my research question and shows that a Santa Ana wind event, which are really strong winds blowing from the mountains down out towards the coast, do increase the growth rate of a wildfire. I do not have anything more at this point. I am going to look into and see if there was missing data or if it really did shrink during those 2 days, and hopefully we'll have that included in my story map for viewing later.